Hello friends, so let us see how you can solve this particular question, question number 2.57, that is GATE 2015 set 2. So without any error you can solve this particular question. Okay, so you can rewrite this particular electric field equation into this form, the standard form. So you have to write the minus of beta of minus z. Okay, so you can say that this particular electromagnetic wave corresponding to this electric field is going in the negative z direction. Okay, so it has basically two components, x component and y component. Now you need to you have to identify the type of polarization. Okay, the state of polarization. Okay, so I have some tricks. So initially, first of all, write this sequence x y z, again x y z. Okay, now for let us in this case the wave is going in negative z direction. So if you define this as positive z direction, then this is as negative z direction. Okay, this must be negative z direction. So this is positive z direction, this is negative z direction, let us assume. Okay, now in our case the wave is going in the negative z direction, so we must consider this particular arrow. Okay, so we can remove this. Okay, so let us write it again. So we have to consider this particular arrow. Now what is the first component near to this bottom of this arrow? This is x, and the second component is y. So what you can write, the delta is basically angle of E of x minus angle of E of y. Okay, to understand the concept a little bit more, let us assume that the the electromagnetic wave is going in the positive y direction. Okay, suppose. So we have to consider the arrow like this way, positive y direction. So this is y, positive y direction. So in bottom of this particular arrow, the first component is x and the second component is z. Okay, so you need to consider delta as angle of ex minus angle of ez. Okay, so let us come back to our point. So in our case, what is the so delta will be, let us write delta. You can directly write, but let us take the difference for x component. So this one is x component, this is the total angle. So it will be your 2 pi into 10 to the power 9 90 minus plus beta z. Okay, and minus the y component, it will be same 2 pi into 10 to the power 90 plus beta z minus pi by 2. Okay, and this is basically your plus pi by 2. Okay, and for delta, for positive value of delta, means your left hand polarization, and if delta is negative, then it is right hand polarization. So in this case delta is positive, so it is left hand polarization. And of course the delta value of delta is greater than 0, less than 180. Okay, 180 degree. Okay, no equal sign. Okay, because for if delta is equals to 0 or 180 degree, in that case you will have the linear polarization. Okay, no circular or elliptical polarization. Okay, so in this case it is basically your left hand polarization, and you can directly say that as ex, mod of ex is what 5, and mod of ey, the amplitudes are this is 3 for ey. So these two are not same, and that is why this is basically your electrical polarization. Okay, so this is how you can easily solve this type of question. Okay, let us face some a little bit complicated situation. Okay, so let me remove all those. Suppose instead of this positive sign, it is negative. Okay, let us assume this is negative. In this case, what you have to do, you have to rewrite this particular equation: ax 5 cos 2 pi into 10 to the power 90 minus beta of minus z. Okay, and then you have to write plus ay, okay, ay 3 cos 2 pi into 10 to the power 9 t minus beta of minus z minus pi by 2 plus pi. Okay, then you can take the same steps to calculate the state of polarization. Okay, so now let us consider another case. Okay, so instead of this cos, if suppose it is sine. Okay, so this is sine. We know that sine theta is basically your cos 90 degree plus theta, right? So you can replace this sine to cos, then you have to add pi by 2. Okay, you have to add plus pi by 2, and if you want to include this particular negative sign, and you have to include to calculate the polarization this negative sign, then it is, if you write this positive, then you have to add another pi. Okay, then you can similarly apply the same steps that I have already discussed, so you will get the state of polarization. Okay, so in this case your overall equation will be your ax 5 cos 2 pi into 10 to the power 90 minus beta of minus z. Okay, plus ay 3 cos 2 pi into 10 to the power 90 minus of beta of minus z, then the angle will be plus pi. Okay, so you can write that x, y, z, and power is flowing in negative z direction. You can write this way. So here x, y, z, so it will be angle of x component minus angle of x component minus angle of y component. So for x component, which one is this one is x component, and this one is y component. Yes, this one is y component. So x component minus y component is basically you will get it as minus pi, right? Minus pi. So delta equals to minus pi, and we know for delta equals to plus minus pi or 0, it is a linear polarization, right? So this is how you can solve this type of problem. Okay, let me give you the chart for state of polarization. Okay, if delta equals to 0 or plus minus pi, in that case irrespective of E1 and E2, it will be your linear polarization. Okay, linear polarization. And now if E1 equals to E2, and you can also write Ex and Ey. Okay, or you can also write those two components by which the polarization has created. Okay, so if E1 is equals to E2 and your angle is plus minus pi by 2, okay, in that case you will have circular polarization. And if your delta is not equals to 0 comma plus minus pi, and not equals to your plus minus pi by 2, in that case you will have elliptical polarization. Okay, polarization. And another condition, if delta equals to plus minus pi by 2 and E1 not equals to E2, in that case also it is your elliptical polarization. Okay, another thing we must remember that if ratio of E1 and E2 that must be greater than 0 and less than infinity, if E1 by E2 is equals to 0 or E1 by E2 is equals to infinity, in that case, irrespective of your phase angle, okay, the polarization will be linear, okay, because in that case one of the component will exist, because in this case E2 is sorry, E1 is 0, that is why this quantity is 0, and in this case E2 is 0, that is why this quantity is infinite. So if one component is 0, in that case you will have only a linear polarization. Okay, thank you.